In this module, we will talk about what is packaging. If you ever open up a laptop or a phone, you'll see a ton of devices soldered down on the motherboard. Many of those devices are packaged semiconductor chips. Packaging is a huge part of the semiconductor manufacturing process. In 2022, greater than 300 billion packages were shipped, all with a value of greater than $60 billion. It's a dynamic and growing industry with tons of challenges and innovations in design, engineering, mechanical engineering, electrical engineering, industrial engineering, to name a few, manufacturing, and the list goes on. All from basic research through high-volume manufacturing. In this section, we'll cover what do we mean by packaging a semiconductor die, why do we package a semiconductor die, and where does packaging fit in the semiconductor manufacturing process? A silicon die contains all the circuitry that's made with transistors. The package is the device that connects the silicon circuitry to the rest of the system. In this picture, you see a wafer that contains the transistors and the silicon die, then the package, which contains the silicon die, that's attached to the motherboard, and that motherboard then goes into a final system like a desktop. So at minimum, a package connects the silicon die and its circuitry to the rest of the system. But it does a whole lot more. It takes the IC chip that is typically no bigger than a quarter with micron-sized features to a motherboard that's typically, like, imagine the size of your laptop with millimeter-sized features. It manages the power delivery to the circuitry, which in some cases, like in data centers or in AI, can be upwards of 1,000 watts. It manages the thousands of signals coming out of that small device. Remember that silicon's the size of a quarter. Thousands of signals it manages to take in and out of that device. It protects the silicon from drops, handling, moisture, and other environmental stresses that can damage it. It helps remove the heat from the silicon so it can run as fast as possible without overheating. And it integrates. So it can be the one single platform to bring together system parts that were typically separate devices on the motherboard. Now we can create a device that's smaller, faster, more functional. This is really the future, and we'll talk a lot more about that. Talk a bit more on dimensional hierarchy and why it is important. Manufacturing nanometer scale size features is a lot more expensive and complicated than trying to manufacture millimeter size features. And when I talk about features, I'm talking about things like interconnects that connect one device to another, traces that make the connections on a layer, vias that make connections between layers. Now, if we look at a motherboard, it is naturally a big thing. Remember the size of your laptop or size of your desktop or size of your phone. And it brings together a variety of different devices, different packages, cameras, graphics cards, fingerprint readers, hard drives, list goes on. So naturally, it has very big features that are low cost and don't require the most advanced tools. So, tools to do manufacturing of motherboards is typically, say, $100,000. Now, the silicon IC is naturally a really small thing because you really want to pack your motherboard with tons of these small IC devices with lots and lots of compute functionality. So naturally, it has very small, expensive features. And this requires the most advanced tools. And these tools, for example, cost tens of millions of dollars. So what the package does is it provides a perfect balance in cost and feature size. And this is a very important aspect to keep our semiconductor devices affordable. You may be thinking, why not directly attach the die to the motherboard? Well, we already talked about feature size and how expensive it would be to make small features on a motherboard. But the motherboard has many different types of packages. A flip chip package, wire bond package, wafer level packages, high-speed packages, high-power packages, low-power packages. Each one of these packages requires different manufacturing technologies and materials. And all those different manufacturing technologies and materials would have to be there at the motherboard manufacturer in order to support these different types of packages. Costs would skyrocket, processes would be super complicated, and it wouldn't make sense to do this when you're trying to manufacture 1.5 billion phones, 500 million PCs, 600 million wearables, and devices for greater than 100 million cars, and that's just in 2022. So what does the manufacturing process look like? Well, it all starts with designing the circuits, the IP or feature blocks on the silicon, then make the IC chips on the silicon wafer. Then comes the packaging part. Test the wafer to identify what are the good IC chips and bad IC chips on the wafer. Singulate the wafer into the individual IC chips. Take those individual IC chips and other components and assemble them all together on some type of substrate or carrier. Test that final assembled device to make sure it works as designed, inspect it, label it, ship it to someone like a board manufacturer to finally make the final system. So in summary, semiconductor packaging connects the silicon circuitry to the rest of the system. It manages the power and signals, it protects the silicon circuitry, enables cooling of the circuitry, and enables spanning many length scales, micron to millimeter. Semiconductor package manufacturing includes test and assembly of the IC die and package. And finally, semiconductor packaging is just a critical part of the semiconductor device manufacturing process and a huge industry. Thank you for watching.